Please welcome back to the stage your host, Matt Dobrege.
All right, good morning, good afternoon, good evening, everyone. Welcome back to the Lattice Developers Conference. As you heard earlier from our keynote presentations from industry leaders, we've got a couple of really major mega trends that are opportunities that we're seeing from our customers and is a real opportunity for our developer community. So we're actually going to take the leadership from our keynote speakers in AI, connectivity, and security, and we're going to take a click deeper for the benefit of our developer community. What we want to do is invite actually a whole panel of industry experts for each of these different discussion topics and dive deeper into the big rocks that are affecting all of the developers, really with the goal of making this real for our developers. So the first panel we're going to have today is going to be our AI panel. So please give a warm welcome to our AI panel here on stage. All right, welcome everybody. I'm going to just do a very quick introduction for everybody. So first, sitting to my left, I have Dennis Lavallee. Dennis is our Senior Vice President and GM of Mirametrix and also our Montreal AI Development Center. Next to Denny, we have Al Mackley. He's responsible for the workstation product line at Lenovo. And next to Al, we've got Ian Cutress here joining us from More Than More. Also, we have Max Versace, the CEO of Neurala, and welcoming back on stage our keynote speaker. Thank you again, Amit, for that wonderful presentation. Welcome. So today we're really going to tackle what is it around Edge AI that we can make real for our developers. What are the big rocks that our developers are experiencing to really take advantage of those opportunities, Amit, that you talked about, but also maybe having a little bit more of a conversation around what are some of the things that we have to do with the community to really enable some of the opportunities that you described. So maybe first, Ian, you have a very unique vantage point on the AI marketplace. I think you cover probably every AI hardware manufacturer or vendor out there. So maybe give us a little bit of a perspective on what you're seeing out there in the overall landscape of hardware and solutions around AI.
I mean, yeah, if we step back from Edge AI, and usually I like to consider there's three main markets here. You have data center training, which is using all the big chips, data center inference, which is mass scale consumption of chips in the data center, and then you have edge inference, which is where Edge AI comes in. Each of these segments have very different profiles in what the hardware needs to be. In the data center training, we're looking at big chips, 100 watts to 1,000 watts. NVIDIA is obviously the big player here. And then we have, actually AMD has got an event on tomorrow, just down the street. They're going to be showing off some new stuff. And then we have startups that are doing innovative stuff in leading edge process node technology, in packaging. Companies like Cerebrus doing the big wafers. And then this is also where we start to see a bit of architecture play in. Different companies like to do different architectures for their machine learning. We've got Google with the TPUs doing massive systolic arrays. We've got many core systems that just look like just an array of lots and lots of cores. You've got CGRA, this reconfigurable array that kind of looks like an FPGA, also playing in that space. And then we go to data center inference, which isn't getting a lot of love right now, but it's ultimately where a lot of the money in AI is going to be. We're talking about Amazon recommendation engines, Facebook recommendation engines. Anytime you use your smartphone and it's connecting to the cloud to do some sort of AI processing, that's AI inference at scale. And then we move on to the edge AI, which is taking that same premise of having cloud processing, but either in a personal device or in a corporate or an industrial setting. And the beauty of that is there are thousands of little players doing this. They're all playing with different sorts of technology. Some of the architectures that I said are going into that, but because with data center training, we're sort of dealing with 100 to 1,000 watts, like I said. Data center inference, we're dealing with chips sort of 10 to 100 watts. AI on the edge is dealing from microwatts all the way up to tens of watts, depending on the system that you need. So we're seeing lots of little companies getting started here with millions or tens of millions of venture capital-backed funding, trying to provide a solution to the market, trying to figure out what makes sense. What's really interesting in this space recently is the adoption, is moving away from traditional compute architectures into the sort of non-von Neumann style designs in order to get super low power, being able to compute in analog, being able to compute in optical. I wouldn't say quantum's quite ready for AI on the edge just yet, but that plays into that sort of non-von Neumann space. And obviously small-scale FPGAs are a big part of that as well, especially in embedded systems where you do have these 5, 10, 15-year life cycles. You need something from day one that supports all of the modern I/O ecosystem to be able to support for the next 10, 15 years. It's getting really exciting. It's sometimes hard to pin down just how many companies are doing this. But hardware is one thing and software is something else, having that. There is no unified software stack. If you're 100% NVIDIA, that's great. If you're everybody else, you have to play with the company's software and optimized libraries. So it gets a little bit difficult, but there's plenty out there to talk about.
Thanks, Ian. That's a really just good overview of all the different computing architectures that are out there. Al, maybe you could just dive into describing, like, just for the audience members, right? I think hearing Ian describe, some of the AI things that have really taken most of the attention in the marketplace for good reason. And thanks to Amit and his colleagues at NVIDIA, it's really taking off. But it's really interesting to understand, like for folks making edge devices like Lenovo, what are some of the types of hardware decisions? What are some of the types of experiences that Lenovo is focused on in delivering at the edge? And how do you look at that? How do you look at that problem in enabling your customers to be able to do edge AI?
Yeah, I think one of the biggest things is that PC manufacturers, OEMs, have always been like one size fits all, right? And this is really changing that paradigm. That you really need more workload precise solutions. And it ranges from, and Ian said it well, it ranges from CPU requirements, GPU requirements, FPGA, ASICs, TPUs, NPUs. There's so many different solutions or requirements for solutions for edge AI, for the sensor collection, whether you want to keep it at the edge, whether you want to have a hybrid solution. And it just all depends on what is the exact solution that a customer needs that will define our end product. But the point is that we're making things much more flexible. We're making it flexible for those that want to develop on CPU. We're making it flexible for those who want to develop on GPU. And then obviously most of the workload-specific applications coming out now are going to be more focused on FPGA and NPU. So, in the future, you're going to see a major shift to things that were more CPU, GPU focused to NPU, FPGA focused.
That's great to hear. Thanks for that, Al. And maybe Max, could you talk about some of the challenges for building edge AI hardware in the industrial market? We got a preview of that from Fred and from Amit's presentation, but maybe you could describe a little bit around what do you guys do in the AI market? Could you talk a little bit about the products you make and the problems that you're trying to solve and how that could tie back to some of the things we could do together with our developers to help address the industrial market?
Yeah, absolutely. So we design software that enables manufacturers and operators in logistics to do real-time quality control with artificial intelligence. And we do that mostly at the edge. And the reason is several-fold. So manufacturers, first of all, they don't like to connect most often to the cloud. They don't want their good products to be, to go out of the factory in forms of pictures. So they kind of don't want that. But there is also a reason around latency, right? So if you're doing a high-speed production line with bolos or other products or coffee pods at 200-300 per minute, you don't have the luxury of pinging the cloud to get the brain information and do it on at the edge. So we are mostly edge focused, but for deeper reasons. And as I was walking here, I was thinking that since you guys are so good in doing live demos, I should do a live demo of how the brain works, which is very different than there is a radical misconception on the edge versus cloud dichotomy. And so Jim did a presentation this morning, and he announced 2 new products. And so I'm asking the audience, not if you're a Lattice person, because then you know, but non-Lattice person, what did he say? What did he announce? Which were the new products? Perfect. So now, if you are an AI system, how would you call that? I answered for you. I've been in AI for 25 years, so I know the answer. So it's called inference, right? So in theory, this is when your AI system interprets information and then gives the output. So you listen to Jim, and the understanding from Jim is that Advanced X and Advanced G are the 2 new products. However, you just remembered it. So how does that work? Is that edge inference? Is that an inference, or is that a learning? And the answer is that the brain does both at the same time. And why am I mentioning this to an FPGA conference is because if you collapse learning and inference in the same computational clock, then you unlock learning at the edge. And that's exactly what we are doing in my company, by the way, but this can be a more common theme, that a trend, if you will, that you will see more and more in artificial intelligence from the algorithm side, right? Beyond all the innovation in hardware that we've talked about that I can comment on, but maybe I'll shut up for now.
No, that's I love it. It's awesome, and I appreciate, Max, that description. Another software panelist we have on stage here is Denny. Denny, you've been part of the Lattice family now for a couple of years. You've introduced all kinds of new technologies onto the FPGA platform, but the real amazing thing is the amount of production volume that you ship in AI platforms. And I think the concept of AI for our developers is still very much in the infancy stage. What could you share on your experience on productization of AI, and what are the important attributes to being successful in deploying large-scale edge AI solutions?
Yeah, I will build on what Al mentioned. If you take, for example, Lenovo, #1 PC maker in the world, Lenovo has a very rich, Al mentioned it, right? A very rich portfolio of products with a horizontal diversity across all markets: commercial, consumer, SMB, some market, financial, government, education. Al mentioned the diversity of computing platform that you can imagine within a rich product portfolio. So as a software developer, the flexibility that he's talking about becomes a complexity in terms of software deployment. So in order to go to bridge from the lab to the commercial world, then we need to have the flexibility on the software side to support the flexibility that Al is talking about from a hardware portfolio standpoint. And you need to intersect a few key things, right? At the end of the day, it's about the user experience. So you need to deliver a novel user experiences, but you also need to intersect across all these different system configuration a similar quality of service at the lower computing footprint possible and at the lower cost possible. So it becomes a balancing act of delivering edge AI in consumer electronics, for example.
That's a great summary, Denny. Amit, welcome back. Just listening to all the different varieties of hardware, clearly NVIDIA has a wonderful contribution to the market with its compute leadership, specifically around AI. If I'm a developer, if I'm a developer, where do I start? How do I go on the journey of saying I want to build a product that's going to benefit at the edge with the help of artificial intelligence? How would you advise someone to start on that journey?
Yeah, thanks. I think we've been working in the space of edge AI for several years now. I think the first product we introduced was in 2015, and back then, even for big AI companies, AI was still a research topic. And we've seen that journey over time. If somebody is starting today, I think the ecosystem has matured so much. The tools, the software stack, the availability and accessibility of compute has advanced so much that you really need to be thinking about the domain-specific problem, right? I think the biggest thing that if you're a developer, you should be thinking about is, what is the problem in my domain that can be solved with AI? And once you have that identified, I think the rest of the tools are available. And especially now with generative AI coming in, large language models, foundation models coming in, the cost of the effort of training a model, customizing it is going to dramatically reduce, right? So that's what I would recommend developers to think about. What is an application in my domain that needs the performance, that needs the bandwidth, that needs the privacy that I can solve with Edge AI? Once you've identified that, identify the data that you will use for that application, then you can, of course, getting started, as I showed in my earlier talk, is like we have high school kids just downloading the SDKs, writing Python scripts, and have their application going. So tying it to the specific domain is the key thing to focus on.
Oh, that's great. Thanks, Amit. Max, just kind of following up on the deployment in the industrial market versus maybe the deployment as described at client compute from Al and Denny. How do you deploy AI solutions in the industrial market, given the number of suppliers, the number of different tools that are out there? We talked a lot about the diversity of sensors, the changing rapidly innovation of sensors. Talk a little bit about how you deploy systems, and how could our developers help you in making more of those customer intersections work for your company?
Yeah, I mean, deploying in the industrial market has its challenges, right? So you're definitely in a real world environment. It reminded me a little bit of my past in robotics, where you don't live in a server or in a virtual world, and you have to get stuff working in a real environment where there is dust, there is noise, there is lighting changes, etc. So it's really challenging. And the way we approach it is we design a software platform, a software solution that works basically on any hardware that you find out there. So we are very flexible in terms of the processor that we can adopt, the cameras, the industrial PCs, and then we collaborate. We partner with integrators, and we have about 40 around the world that whenever there is a manufacturer that needs a solution, we have the integrator chip in and design a full solution that involves much more than the AI, right? So it involves the AI, involves cameras, involves integration with PLCs, sometimes involves robotic solution, extruders, and all the jazz that goes with a real-world implementation. So it's a challenge. It's going from theory to practice, but it's definitely an effort where you create an ecosystem of partners, pretty much as you're doing, and then you go and tackle those real-world challenges.
Oh, thanks, Max. Ian, one thing that I've experienced working with customers around Edge AI is, a lot as you map the right application, or as you look at the right domain that you're trying to apply AI to, there's a lot of different frameworks. There's a lot of different models. Yeah. Like when we talk to new customers, and by the way, every customer is engaging us with AI either because their products now have AI in them, or they're using AI to make their products. And they don't know where to start in the concept of which frameworks, which models, they're changing so often. How do we think about that, and how do we think about that with some of the best way to map that to hardware?
It's so that's really two questions. One is about data, and one is about tools.
Yes.
Right. So on the tools side, you mentioned frameworks. These are things like PyTorch, TensorFlow, Onyx. These are the sort of highest level abstraction layers that you can use to implement your machine learning solution. And we're seeing rapid adoption of those, even for hardware that has a domain-specific language. If you can abstract it away, more people can get involved. That being said, some of the biggest companies on the planet who are deploying these solutions, they don't want high-level languages. They want low-level. They want to be able to write their own operators and abstract the most performance they can out of their solution. You'll hear things like maximum tops per watt, or performance per watt. And this hardware that companies are putting out, in order to abstract those numbers, you need to have a low-level understanding, and there's an incredible, insatiable demand even for engineers who understand low-level hardware, whether it's publicly available hardware or even sort of like niche startup hardware stuff. Everybody's realizing that you need a two-tiered tool solution to provide for your market. The other thing is data. And right now in the sort of couple, 2-3 years that machine learning has taken off, everybody's been talking about training models. How do we get lots and lots of data to train models? We're starting to see the development of something called foundation models, where these are large sets of relatively unlabeled data that you can get a model to train itself. There are very few companies in the ecosystem who have the budget, the size, the capacity to build large foundation models. And one of the big ones is GPT, right? Large language models. But you also have you have large foundation models coming for industrial automation, for detection, for research with physics, chemistry, geospatial data, for being able to predict weather. Those are coming. What we're seeing now in the marketplace is a bunch of companies appearing who are doing what's called fine-tuning. This is where you take your large foundation model, we're talking about billions and billions of parameters, required gigabytes and gigabytes of memory. And what they do is, rather than train a model, they take a pre-trained model and then they have some small amount of labeled data and maybe retrain 10% of the model for a specific use case. In language, for example, this is you take a GPT and then you want to optimize it for the help service for your website. So you need to retrain that chatbot essentially on your specific data. That could be lots of help documents, but then also take it one stage further in healthcare. Now, a lot of healthcare data is private, and you need security around that. So there are companies now taking those large models, adopting fine-tuning, and that becomes a more cost-effective way for it to be adapted onto hardware. Then you put in things like pruning to reduce the memory footprint. Maybe you're doing it at a different quantization level, which also helps with the compute, bringing it down to lower powered devices. So we're going to start to see a lot of those fine-tuned models hitting consumer devices that the consumer actually interacts with rather than be passive. And the point is, the ecosystem is wide open. Nobody knows where it's going, least of all the people who actually build the tools, right? During the gold rush, nobody knows where the pickaxes are going to be used, and the person who's most surprised is the pickaxe vendor themselves. So this is what's going to happen in AI hardware, and the tools, just insatiable demand for developers right now.
That's a very interesting point. We were listening to an IDC presentation, and they talked about how some of the first hardware that's going to be generally available for most AI development work is actually going to be workstation products, because they have the balance of performance and mobility and capability to use some of these foundational models to go and build these killer apps, so to speak, or the ones that we're all excited about. So Al, maybe talk a little bit about, when you go to design around knowing that that's coming, what are some of the things that you look for, in a partner? What do you look for in just the overall development of those products to the AI market?
I think first we want to deliver a development platform to the industry, right? Whether and I mentioned it before, whether it's going to be GPU based for your very high end number of tops that you can get out, floating point 16, or maybe NPU based that's a little bit lower level, things that are going to be, I would classify GPU based as the development platforms for model creation, model development. NPU is going to be more background task oriented, things that are going to be happening on device for smartification, intelligence of the system, and really what we want to do, and it gets to Ian's point, is the first systems that you'll see the ecosystem is still being developed, and really it's all of you that are going to be developing that ecosystem. So the first thing is get the hardware out to the users to develop these applications, to take advantage of the new CPUs that have NPUs in them, to take advantage of the FPGAs to create that ecosystem. But in parallel, and that's the second point, in parallel, we will talk to vast, many customers. We'll have development advisory councils, face-to-face meetings, one-on-ones. We will get input into what people are doing across different verticals to see how we go about creating those software stacks that will be unique for each individual vertical and even the workflows inside of the verticals. So right now it's very much a learning exercise in what people are doing. I think first and foremost is getting the platforms into the hands of the developers to create this ecosystem.
But if I may, building on that, you also need to dumb it down, right? I mean, we need to quickly have the tools. I mean, organizations cannot have PhDs doing this.
Yep.
So now that we have proven from a hardware standpoint, software standpoint, that edge AI is possible, we need to dumb it down and to have the tools and the framework so that almost say non-experts can develop their own applications.
Yeah.
Well, this comes down to something that I've been speaking to FPGA companies like Lattice all the time, the ability to abstract away some of your most difficult compute to understand through libraries. And we're doing that through frameworks today. But they also have to be agile. So to a certain extent, I've known developers who don't care what hardware is underneath them. They just write at such a high-level language. They want it to work first. And then optimization will come down later, and we have a GPU with so many threads, or we're using CPUs, or we need to get it under your 5 watts to run in a phone. That arguably comes later after solving the solution first. I mean, transformers is a massive example. The whole industry went from convolutional neural networks for visual inferencing to transformers for language. And the ones that succeeded were the applications that could pivot on a dime, could transform their models into using the latest and greatest technology, so it was applicable to the widest audience possible. Nobody knows what the next step function is after transformers, but there's a lot of people working on it.
Should the developers right now just focus on so if I'm a developer and I have an awesome new Lenovo workstation and I'm running awesome, NVIDIA GPU hardware on there, should I go find a transformer model and figure out how to go build an AI use case for a transformer model? Like, how do I design in a software environment knowing hardware diversity? Like, how do you coach someone to take that first step in terms of investing on a model? That's kind of the follow-up question there, Ian. Maybe
it comes back to what we were saying before, domain-specific problem, right? If your problem isn't language, don't use a language model. That being said, I've seen some weird things with images and language and audio with stable diffusion. So there are lots of people playing, but you really have to define what your problem is. You can't just be a general purpose thing, especially when it's edge, when you're looking for extracting the highest efficiency out of it. So
maybe the panel could talk a little bit about the use cases that right now across your different business models you believe are the killer apps. Like, if there's opportunity, like the gold rush, so to speak, Ian, if you're going to go run to a certain kind of application across your different verticals, maybe each of you could talk about what are the things right now that you're seeing that are killer applications, whether they're the work we're doing at Lattice or the things, Al, you're doing at Lenovo. Would love to hear just from the panel on what you're seeing as some of the killer apps that maybe our developers could focus on.
I mean, from my point of view, it's stable diffusion is the biggest one from a workstation perspective. Yeah, high fidelity, generative AI from an imagery perspective. It's just. I mean, I don't know if you've seen the stable diffusion XL recently, but it's just unbelievable as you're typing, just creating high fidelity HD content right in front of your eyes. I mean, it's fantastic, but and that plays into many different workstation verticals. So by far, stable diffusion is the key application and workstation.
I was using it this morning, so.
Yeah, yeah.
What about you, Denny? What are you seeing out there in the marketplace that you could?
I'm biased, right? So I spent the last 10 years working on what we call attention sensing. So to enable devices to be user aware. So the concept of smarter devices, pioneered by Lenovo back in 2017. We just saw a spectacular demo this morning in an industrial context, right? So security and safety in a smart manufacturing floor. And I think that we're just scratching the surface in terms of novel user experiences that we can bring to market, human-machine interaction. I think we're literally just scratching the surface. I'm not even talking about multi-modalities, vision, audio, speech. So from a innovation in terms of human-machine interface, we're just at the beginning of a spectacular generation.
It's, I speak a lot with companies that create consumer-focused devices, so it's all about the interaction with the consumer. And to be honest, aside from what we already see on a smartphone, there seems to be very few killer apps that can be scaled up to, say, laptops and stuff that isn't already in a smartphone. However, as sort of an anecdotal personal preference, I like to see push towards improving efficiency in the designs. It's something that runs in the background that users don't necessarily buy the product for that reason, but it's a very nice to have. So if you can showcase a CPU, GPU combo in a laptop that is able to drive down to sleep quicker due to using algorithms to determine workload, realizing that some workloads aren't latency sensitive, so you can run them in a more power efficient mode. We're already seeing companies look at gaze detection. So if you're looking at the screen is on. If you look away, it powers down the brightness of the screen, and you save battery life. That's efficiency. I mean, we're seeing laptops today now speaking about 12, 14, 16 hours of active battery life. Machine learning perhaps put that into sort of the 20, 25, 30, if we find out different ways in order to save power.
No, that's meaningful. Max, what kind of use cases are you seeing from your customers?
Yeah, I mean the interesting part, Matt, if I point you something right now, the most important thing that will happen is that it will be obsolete tomorrow, right? So the thing that I noticed, having been in the industry for a very long time, is that the rate of change has changed, right? So it's the derivative sort of the innovation has dramatically changed. And all these quantum leaps, we just witnessed the latest quantum leaps with the transformers. Now we are at the stage where the utility of this application is out of the question, whereas when I started, people were laughing about neural networks. Now nobody laughs anymore. And so the applicability is now so obvious to everybody that the rate of change is changing at the pace that is incredible. And so how do we future-proof this from the hardware perspective, right? And so if I look historically, if the brain is here and the hardware is here, and I come from the brain science, right? I come from computational neuroscience. What we have seen in the past few years, sort of these two lines converging. And so if we talk about transformers, they incorporate concepts such as attention, reinforcement learning that were known in the literature for 20, 30 years, but now they are finally embedded. And so the good news and bad news is that there is a finite set of things that the brain does that hasn't gone into AI yet. The bad news is that this set is larger than we think, right? So what I'm interested about, what I'm intrigued about is the ability to customize things at the edge. So kind of, merging this idea of low power edges with the idea of customization. If you're thinking, for instance, of a cell phone user, and we deployed on 60 million devices, how can I personalize the AI, whatever that is, in the phone of the user without shipping any data out of the user? So that to me is important if you're thinking about FPGA, learning on device configurability, intersecting with security and safety, etc. And also, what's the impact of that on data transfer, data bandwidth, etc. So that to me is exciting, and it's kind of an horizontal application of a concept across many different domains.
That's great. Thank you so much for that, Max.
If I could add to that
Sure.
as well, Mass mentioned the rate of change. I think we're just at the tip of the iceberg with rate of change, right? I mean, before ChatGPT, AI really wasn't that much of a discussion. After ChatGPT, now it's mainstream, and the game has changed. It was CPU, GPU before, and now and I keep going back to this, now with FPGA, Lattice is a big driver of that. With NPU, the rate of change is going to be exponential from here on out, right? The rate of change of usage, making systems smarter, the rate of change of the ecosystem and development, application development, it's going to be, from here on out, it's going to be, and I would say, keep your eye on the space between now and the summer, because it's going to change very, very quickly with some new technology introductions.
We're still going to be alive after the summer. just checking.
That is true. That is true.
Or you have other information.
Al is not calling the AGI
No.
inflexible. He's not calling.
No.
So with mainstream AI, because I think you're right, I think there is a sense of, to editorialize a little bit, I think there is a sense of mainstreamness. At whatever level we thought we were at before, it feels way more mainstream now. And with mainstream comes regulation. And one of the conversations around regulation in AI that I think every nation state is thinking about is just fair AI, and how does AI ultimately, influence or create an inference based on the data set that it's trained on. So maybe Denny, just to kind of provide an overview of our approach to fair AI, maybe talk a little bit about some of the things we do at Lattice around our data training and how that impacts the products that we developed, and maybe we could set up the panel for their feedback on what they're experiencing there and just some guiding principles that they could help our developer community with.
Yeah, so I think that I may come from a different school on the subject, in a sense that, life is not fair, right? So let's start with that. So to me, it's all about the expectations with AI. And we cannot expect AI to be perfect. So we're not perfect. AI will not be perfect. And so to me, it's about, if you engage on an AI program, you have to understand and you have to take into account the total cost of ownership of that project. It's an ongoing pursuit. And you need to have an evolutive maintenance program that will take into account edge cases that you will always find as you use the system. So to me, in terms of the fairness of AI, it's having the maintenance that you need to implement in order to address the edge cases that you will always encounter.
So just to translate for the audience, I think what Denny you're saying is, when you say maintenance, you mean, hey, as you're working on AI models or AI deployments, you run into corner cases that you might have not had the training data set when you built the model, and you may need to have iterative change to be able to adapt to that, whether that's a user's profile, or that could be a scene or something in another use case, whether it's automotive, et cetera, where you have to constantly be, it's kind of like total quality improvement type of message.
Well,
right?
it also goes back to the concept of failure in AI, and what's our expectations in terms of how can AI fail? And to me, the red line is, I need to understand when AI fail. If I don't understand how AI failed, then I start having a problem. A good example to me is, I have a problem when a Tesla car kills the driver by ramming into the back of a fire truck on the left lane of a highway in sunny California. I have a problem with that. But if I see AI failing the way that my brother-in-law fails at times, I'm like, oh yeah, I can see that. So to me, the bar for AI is my brother-in-law.
We need some background on your brother.
No, but it's about the social accessibility of AI, right? So we need to understand, when AI fails, we need to understand it. And if we don't, then we start having a problem. At least I do.
No, it makes sense. Makes sense.
It's the measure of human fallibility. It's if people are 90% accurate, does AI only need to be 90% accurate? It's in order for adoption, usually people need that order of magnitude difference. And the reality is, it doesn't necessarily need to be in order to be effective.
Exactly.
Yeah.
Well, I have a friend of mine who is a medical doctor, and he told me somebody has to be last in medical school, right? So, so when I go to a doctor, I'd rather have 99.9% AI than that guy who was last.
Yeah, yeah.
I don't know about you, but
It's one of the difficulties we have with this fairness is when we speak about, say, stable diffusion generating people, making sure we have a fair cast of characters when you ask for people. That's fairly easy to identify, and that's what a lot of people focus on. When it gets to medical data, maybe you end up with a very white middle-aged focused data set, and sometimes that's not the best way to recommend or detect cancers or recommend treatments. If we go a stage further and say, well, what does that look like in the industrial space? It's a very difficult question to ask because it depends, A, on what your problem is, B, on what your data set is. For language, it's been fairly okay because we've got such a large language data set, and there are edge cases where it doesn't seem to be working, and you can argue whether ChatGPT has actually gotten worse over the last 3 months based on how they're training. But a company like that is deciding what's the right level of accuracy for the cost of the service we're providing. As we move obviously to the edge and some of that stuff comes away from the cloud, accuracy versus latency versus whether your model's fair all becomes part of how you need to design your machine learning algorithm, and that's a very difficult question to answer generally. Narrow it down to a problem, and maybe you can find a specific use case or a set of test cases to enable that fairness.
Maybe Amit, clearly NVIDIA has a major stake in describing to the community what fair AI is. Maybe you could just share some of the guiding principles from your perspective?
Yeah, I think we take intellectual property and very seriously, and that's why we are investing so much in providing these frameworks and tools where enterprises can design their own sovereign models with their own data sets. We recently announced an image generation product with Getty Images, which is all licensed and responsibly sourced data sets. So it's possible to build these models, large models, foundation models, with data sets that have been responsibly sourced and with the right legal permissions on it. And so our mission is to build that platform that will allow enterprises, countries, states to build their own model with their own data sets, which is responsibly sourced, curated, so that you can depend on them and rely on them.
No, that's wonderful. Thank you, Amit. And just to Denny, back to you on the training that that Lattice does for some of the solutions. Can you talk a little bit about how do you think about development on software, the training that you do on software, and how does that play out into an end system solution, right? Because in some of the demos that we shared previously in the developers conference, we showcased an industrial solution, right? That wasn't hardware and software separately, that was a combined solution. Can you talk a little bit about how do you connect those pieces if you're a developer? How do they engage? Do they engage with a software company? Do they engage with a hardware company? How do you walk that development cycle for a developer?
Yeah. So in our case, we actually start with the user experience. I mean, we will always start the conversation with the user experience, regardless of the hardware, regardless of the software. The number one question that we're going to ask any customers when we start engaging on an AI program or project will be, what user experience do you want to enable? And from there, we derive an implementation strategy that will include software optimizations based on the hardware platform that we have, because at the end of the day, it's going to be about delivering the best quality of service possible at the lowest computing footprint possible and the lower power consumption possible. And then there will be the training set in order to support that use case or that user experience. But it's also, it's for us as a software developer, we always start with the user experience at as the starting point of the conversation. And then when it comes to training, we do a few things. We create our own training set. We now have fantastic tool with generative AI where we can accelerate that work of developing training sets. And then again, there's a optimization phase where you always have to improve the system over time, but always driven by the quality of service that you deliver and the user experience, the quality of the user experience.
Oh, that's wonderful. And again, for any of our attendees of our developers conference, all of our panelists have full biographies and contact information on our website, on our developers conference module. Please feel free to take a look at the demonstrations that their companies have created to showcase some of the AI technologies that they're driving. And that's going to be a good repository to kind of keep the conversation going. But we still have time for a couple more discussion topics. So, Ian, you've been a great contributor in terms of giving us the market landscape on the hardware side. Can you just talk a little bit about what should our developers expect from the sensor diversity and how that's going to impact their ability to make decisions on how to formulate some of those use cases that Denny is talking about from a user experience perspective?
So from my perspective, it's all about making sure that a solution is scalable, right? Especially if you are tasked with generating a specific or a generalized endpoint that could be used in specific cases that somebody else might further take down the line. We're seeing sensor fusion as a great example. It's matching something that FPGA has been targeted on for quite a while and mixing it with machine learning, the ability to combine those two together and making sure a solution is scalable over time. I'm very much in favor of developers having lots of access to as much tools as they need. We're starting to see this concept of having the full stack developer. It's not simply someone who understands software, it's somebody who understands software and hardware. So to your point about doing the user experience at the end of the day, it's also going to be deployed somewhere. So you've got to think about optimizations you can do with that specific deployment in mind. Abstraction is great. I'm seeing lots of demand for more focused knowledge in a lot of cases.
That's great. Okay, well, first of all, I want to thank each and every one of you for just a great discussion. I want to thank you for participating in our first Lattice Developers Conference. Just again for the audience, all of our panelists are available with their information online, so please feel free to reach out to them with any questions. And I also want to remind everybody that from an Edge AI perspective, this week as part of our Developers Conference, we've launched a whole portfolio of new tools that really touch on some of the model frameworks, the fair AI requirements, and some of the things to actually be able to deploy these solutions at the Edge AI. So please go look out for those modules from the rest of our marketing team, shameless plug. But again, I wanted to just thank everybody for their participation, and thank you. Enjoy the rest of the conference.
Thank you.